thanks a lot for the invitation to this conference. I'm quite happy to be for the first time at PyCon so it's a real pleasure. So just to start with some introduction, my name is Kacper Łukawski. I work as a developer advocate at Qdrant. Also run a AI Embassy Foundation, which is a non-profit organization focused on spreading the knowledge about AI, but on a mostly on a basic level. But today I'm going to talk a little bit about some programming tricks. And I don't want to pretend to be an expert in that area, but during my career, I was working in mostly in a software house where I was dealing with many different projects, many different clients, and I also met some inspiring people that surprised me by their laziness. Let's say those were the brilliant lazy minds who preferred thinking over doing things. I was on the other side, well, actually I was quite surprised to see that there are so many people who really want to think how to deliver the things without taking too much effort. And due to that, I decided I would like to show some of the most interesting tricks that I was able to see during my whole career. And actually, it all started during my studies. The first year at my university, I was studying in Krakow at Jagiellonian University. I realized that there is a smarter way to swap two variables, other than creating a temporary variable to just do it like in an obvious way. This actually doesn't apply to Python, right? Because we can do it in a single line of code. But back in the days, while using C++ or any different languages, that was still the optimization. Of course, making the code looking ugly, but still saving some memory. But when I started my career, I also realized that data scientists, like data analysts I was recruiting to my previous company, do not know much about the modern SQL. Actually, all of the programmers, probably all of us know some basics of SQL or SQL language, but typically there are some features that are quite commonly unknown, and I was quite surprised to find out that there are some people who don't know things like common table expressions and prefer using a lot of subqueries, which are not necessarily optimized. At least they were not optimized in some previous version of the most popular engines like MySQL. So if you do not know this syntax, with the modern SQL, actually all of the systems that I work with have it implemented. You can create some kind of alias and refer to this alias in the further parts of the query. That makes things a lot cleaner and allows you to basically divide your query into several steps. Well, depending on the system, that might be optimized better or worse, but still, when it comes to readability, it's probably a better way, and definitely better way if you want to like present this code to somebody else, or if you will be forced to read it again in a few months. And another thing which is quite related, it's another concept which are window functions, and those functions allow you to calculate some values over a specific subset of your whole query. So in the past, if you wanted to, let's say, calculate some values, some statistics over over each partition of your data, you would need to either write a loop and evaluate a single query over all of the partitions. Right now, you can use, like in this example, a rank function and get it calculated directly on the database level. And that simplifies a lot. And it's not necessarily a trick. It's like a feature which is quite commonly unknown. So hopefully you will find it useful. But there are also some things which are related to tricks. sometimes we want to implement some things in a simple way. And that's not necessarily our fault, but maybe it is caused by wrong assumptions. We live in a specific area of the world, on a continent, and sometimes we just assume the world looks exactly the same all over the globe. But it's not the thing. In the past, when we were mostly working with C or C++ or any older languages, let's say, there was a trend to use sentinel values, so values which have a specific special meaning in order to define some conditions. So that might be a 0 byte which defines the end of the string, but also a new line character. Those characters have some special meaning, and that is fine unless you work in a specific domain where that may lead you into troubles. And that happened quite often, and one of the examples is StatGraphics, which is a statistical library that was using this specific integer value as a sentinel. So they were just simply assuming if that occurs, that it has some special meaning, like in this case, a missing value. We would use null in this in all the languages that we currently use, but they decided that this specific value will be marking a missing value in all the data sets, no matter what user may have in this data. And basically that caused a lot of trouble. People were not aware of using this using this value may lead them into troubles. And as you may imagine, if something may happen, it will happen. And there were some cases where that was leading to some issues with calculating some statistics out of this data. But it was not big data back in the days, so people were typically quite able to find out it quite easily. But there are also some other issues, and this is there is a huge list of falsehoods that programmers believe in, and those are about names. Here I just mentioned some of the most important ones, like assumptions that people will have only exactly one canonical full name, or people will have exactly n names. There are some assumptions that we are typically used to living in a specific country, but this is not true all around the world. And there was quite a famous case that happened a few years ago. I'm not sure if this platform is still being used, but in ActionScript 3, there was a case that they were interpreting null as a string as if it was a missing value marker. So that was evaluated into null instead of being represented as string. And that worked pretty well for a long time, but once there was a guy called, with a surname null, that was a real surname, and that caused some issues. That was quite a famous case. Maybe one of the reasons why ActionScript is not used anymore. Okay, but I promised to talk about tricks, so I would like to start with regular expressions. So they are quite commonly misused. People use regular expressions to parse HTML, which is not a regular language. Well, if that works for you, then it's fine, but there are some better ways. But they are also quite useful. And there are some specific tricks which might be used with regular expressions as well. So if you ever struggle with them, maybe you will find it useful as well. Let's say we want to solve this kind of problem. We want to find a specific word in a text or specific pattern, but only if it's not enclosed with quotation marks. Sounds easy, right? Well, in that case, that could be done without regular expressions for sure, but let's say we need to use regular expressions for any reason. I don't know why. Okay, so in this case, Tarzan without quotation marks will probably mean a name, and Tarzan with the quotes around will be probably a movie name. So that there is a huge difference in meaning. So that's, let's say it's a valid use case and maybe something that might be used in reality. Well, if we wanted to solve it, then there is a first way by using the negative look ahead assertion and look behind assertion. And our regular expression starts to look like this. Well, if I wanted to describe it in a few weeks after, then probably I would need to go into the docs just to find out how this negative and look behind assertion should look like and what they mean. This is not that easy, given the problem that we had from the very beginning. This is quite a complex solution and quite hard to follow, right? Believe me or not, this works. But that's not necessarily the best solution to the problem. But there is another process. Another process is to divide this problem into two parts. First of all, we would need to replace the occurrences that we don't want to, like the ones with the quotation marks around. So we could replace those quotation marks with some other values and then match, because that would be all fine. But still, we need to choose some sentinel values. That may give us another troubles, because if we replace those characters by some different characters, maybe we can also destroy something else. But there is also the best regex tricks. The best regex trick. This is quite well described on the website that I linked here. But basically, this complex regular expression could be represented in a different way, something like this. So the first example and an alternative. So the first example without with those quotation marks will not be recognized just because there is no group. It's not enclosed group. So it will be just mapped to an empty string, and that's totally fine. Here, let me just remind you that was the original sentence we used. So there is Tarzan without quotation marks, and then the following one with quotation marks around it. And here, with this regular expression, we were able to recognize both, but the second one was not returned as a proper group, just because it was not it was designed that way. And if we wanted to have some other exceptions, things are pretty easy. We can just put another alternative and also exclude those ones which are enclosed with single quotation marks. This is fairly simple. But if you use Python, and I bet you do, there is also quite a useful way to check out your regular expression, because you can enter the debug mode just to see how this is going to work step by step. Just for debugging purposes, seems quite useful. Okay. But all of the examples that I've shown so far seems like some dirty hacks, and back in the days, those tricks were typically used when we wanted to optimize some things. Right now, we do not care much about the memory constraints. We can have like 64 gigabytes of memory on a laptop, so that's that's fine. But still, there are some specific domains in which we need to care about those constraints a little bit more. But in the past, there was quite a common case of leaked code of Quake 3, and the way that they implemented farce inverse square root. I believe some of you already know this example, because that was quite famous. I'm not going to go into details here, but the whole idea of that was to calculate 1 divided by the square root of x. That sounds pretty simple and something that shouldn't be optimized, but in the past that wasn't that obvious. On the right-hand side, you can find the original source code of that function that was implementing exactly this process. Just without going much into details, there is the thing about how floating point numbers are being represented in the memory, and that was interpreted as an integer. Still, if I was to determine what this function is going to do, I wouldn't be ever able to do it. Probably just by looking at the source code, I would never know what is the purpose of that. So that requires a lot of comments, and they are put just next to each line. show what is the meaning of each of them. But basically, it's not something that we need to care much about nowadays. There was also another famous case, the programming anti-hero. That happened in the game dev. One of the companies was implementing a game, and well, there are some consoles have some like if you were to implement a game for PlayStation, Xbox, or any different platform, you need to consider some memory constraints. So that was the case here as well. They were trying to optimize a game just to fit it in the memory of the device that it was written for, and they still needed like 1.5 megabytes of memory. They were trying to remove some different things, optimize, store it in a different way, but at the end of the day, they asked one of the most experienced programmers how they could solve that, and the answer was he got to a specific line of code where he reserved like 2 megabytes of memory, just because he knew from the very beginning that they will need some more to work properly on the device. And that was the solution. So if you are the guy in your company, then chances are it will be quite hard to replace you. So I would probably negotiate my salary in that case. Okay, but this is not the optimization I would try to encourage you to use. As we are in Python community, I would like to show some Python-specific tricks because there are plenty of them as well. And first of all, if you would like to know the Zen of Python, it's already integrated with the language itself. The only thing that you need to do is to import this, and the Zen of Python will be displayed on the console. I'm using that quite a lot instead of using lorem ipsum. That works pretty well and looks much better than this artificial languages being generated. But if you ever wanted to serve some files over HTTP, that happened quite a lot back in the days. And there were some specific pieces of software that you needed to install. Well, at least installing some web servers like Nginx or Apache were the solutions. But there is also a built-in HTTP server in the language itself that can be launched within a single line of code. This is specifically for Python 3. If somebody uses Python 2, then rethink that first of all, and then try to figure out how to do it. There is another way, but honestly, I don't remember the package name. But this is also built in. So if you need to serve some static files, things are rather easy. That will automatically serve all the files from your current directory. Well, at a different conference I attended this year, there was a great talk about testing in general and testing the documentation. And it seems like Python is the best language to do it, just because there is a specific package that's also built into the language, which is called doctest. And if you have a rather simple library that you implement some mathematical operations, like in this case, adding some numbers, that may be quite easily integrated. If you use the specific syntax, you can simply have the tests integrated into your documentation. First of all, this is considered anti-pattern nowadays, but who cares? If there is a way to use it, well, basically that allows you to at least keep up to date with the current interface of your library. So if you have some simple functions you would like to have tested, integrating that directly into your code base is a great way to start. Well, I would say better test your code this way than do not test your code at all. And that's the rule. You can also expect some exceptions to be thrown by a specific call. So this is fairly easy. Well, dependency injection. For those who come from JVM world, this is quite an obvious thing. But for those who work with Django or Flask, the introduction of Fast API was quite a hard switch, because there are some concepts which are unknown in the past, like dependency injection, something that I love about Fast API. just because I can do it in a way that simplifies a lot, providing some additional dependencies to a specific piece of code, and that allows to test every single piece in separate. Okay, but there are probably also some people who are interested in machine learning. I at least assume there are, as usually on any Python event there are some data scientists working with Python. So I have some tricks for you as well. Okay, first of all, some introduction to neural networks. This is quite a common example. We have a network that takes some images as an input and decides what is the class or group of objects this specific image belongs to. In the past, we had to label the data manually. That was the hardest process of the whole data science project. We had to collect thousands or millions of examples and then manually label them with a specific set of names. Well, this is still fine as long as we label some images, because we can play some audiobooks or just music in the background and click on a specific label for every image that is being shown to us. But if you want to annotate some videos or audio signals and mark some specific time codes as well, this is fairly complex and may take you like months to do it properly, and this is also the most boring stuff that I have ever worked on. So some lazy minds decided that maybe we don't really need to annotate the data manually, but maybe we could try to do it in a smart way. So we can put some examples as an input of the network and the same example as the output, and try to put those images in that way so the network will be able to reconstruct them, or at least reconstruct some kind of variation of the original signal. But the whole goal of that is to put those examples into through a layer which has a low dimensionality. I mean low dimensionality comparing to the original input. Let's say we have like a 4K image as an input, and if we are able to put this 4K image into the layer which has like 500 neurons, then we can somehow compress the original input. And if our network is able to reconstruct this original signal based on this compressed representation, then it means that we found quite a good compression algorithm done specifically for our use case. And this might be thought as a different representation of the original signal, and we call that embedding. This is quite a hot topic nowadays, and this whole network is called autoencoder, just because the first part is encoder and the other part is decoder. Okay, so if we are able to do that, then we could compress the original signals and reduce the dimensionality. That's a good news. But also, that could be useful for some other use cases. Let's say we are able to create this autoencoder and remove the decoder. And then we would end up with a network that is capable of compressing our signals. And these compressed signals should capture those regularities that are already in the data itself. So then, we could try to use this compressed representation and put some additional layers on top of that, just in order to perform the classification, for example. And this is quite commonly used approach. If you have heard about BERT or similar models, those are language models, not necessarily autoencoders, but they rely on embeddings. They try to map each word from given sentence into the embedding space, which is like a numerical, low-dimensional numerical space. I used to say it's high-dimensional space, but it's not, because it may have like hundreds of numbers comparing to the original language. It's fairly low-dimensional. And then if I apply new head, we can simply train a classification network on top of that, and that's fairly easy. And there are a lot of pre-trained models separately for text, separately for images, for audio signals, and actually for all the data types you can imagine. So if you could have a good general usage model like BERT, we could try to use it and fine-tune in order to solve a different problem. BERT was trained on, let's say, whole internet. It used Wikipedia as a data set for the training. But if you work in a specific domain, I used to work for the railway company, and we were implementing a chatbot. The thing is that if you implement a chatbot for a railway company in Poland, people will typically try to ask you some different questions or try to argue with you, try to ask questions which are specific to this domain, right? And that happens in every single area. So those general use models are not necessarily designed for that. But we took this model, we fine-tuned it, so it was working a little bit better on this specific domain, and that was working quite well. And the approach that is typically encouraged to use is to use this neural encoder, put a new head, so those original embeddings will be just adjusted a little bit compared to the original ones, and run this process again. But if you look at the network structure here, and if you read any tutorial of training neural networks, you will be still encouraged to, in every single epoch, load all the images, put them through the network, and then recompute the error to minimize it. And that will be the thing. We will be reading a bunch of images or just loading them from some external sources in every single epoch, or we'll put them in a specific place, but still there will be a huge overhead. And in the typical setup, we try to freeze this neural encoder so it becomes deterministic. So as you might imagine, there's a lot of computations which are not required. If we are able to cache those original embeddings and just train the new head which is attached, then things are fairly simple. And that's the thing that I was quite surprised to find out that nobody was doing. Because all the tutorials were encouraging you to still train the network from the very beginning to the very end. So at Qdrant, my company, we are doing open source vector database, but we also implemented a Quaternion, which is a PyTorch Lightning extension. This is a library that actually allows you to do exactly this thing. So we introduced a caching mechanism, and this caching mechanism automatically takes the original embeddings and put them into your GPU or CPU, depending on when you train the network. And then every single epoch takes no hours, but seconds or minutes. So, well, I like my data scientist job when I was just training my model for days and spending all the time in the kitchen sipping some coffee. But it had to stop just because with this setup, I can train the network within minutes, at least fine-tune an existing network within minutes, just to find out if that's a proper direction. And that's compatible with PyTorch and PyTorch Lightning, so if you use those libraries, then you can easily integrate it as well. Okay, but this is the time for some final thoughts. How did it start? In order to propose those examples, I didn't want to pretend that I'm the expert in applying some different hacky tricks. So I asked Hacker News community if they have some examples of what was shocking to them during their careers. And that was quite a well upvoted topic. That was my first post on Hacker News, and that was for quite a long time on the homepage. So I was quite proud of it. And there were some ideas that I especially liked, and this is one of those. Replacing arrays of structures with structures of arrays. This is like a different paradigm. We have row-oriented databases and column-oriented databases. Depending on what we want to do, if you wanted to calculate some statistic based on some specific columns, it's way easier if you just replace those arrays of structures with structures of arrays, just because they will be close to each other in memory. But there was also one idea that I especially liked, and this is exactly this one, you could harden a Linux server by killing the init process. So that would cause a kernel panic, and and also prevent new processes running. So you won't be even able to SSH into the machine. But existing processes like web servers will be still able to run. So if you care about security but do not have a budget for that, then you can simply disable the possibility to access the server. And the only way to access it again is to unplug it. So that doesn't work in cloud, unfortunately, but still, that's... I haven't tested that. Actually, maybe something was simply lying, but basically, that seems like the worst, but also the best idea that anybody suggested. But in reality, using any kind of smart tricks is considered an anti-pattern, unfortunately. Nowadays, we care more about the readability of the code, because there is a lot of software that has to be maintained. Requirements change over time. So the best thing that you can do for you and for your colleagues is to write a code which is easy to follow, easy to maintain, and easy to test, because compilers or interpreters will also optimize what you do, so we do not care that much about optimizing anything. Okay, actually I left some time for questions, but honestly I don't believe if there are any questions to my presentation, but hopefully there is a story that somebody would like to say. Well, there should be a video, but my internet connection is really bad here. If you are interested in seeing more about what we do, here are some links and the QR code links to the Qdrant website. Maybe a few words about Qdrant. Qdrant is a vector database, quite a new tool. We are on the market for less than a year, but we are also like the third most popular vector database. And vector database is especially done for performing approximate nearest neighbors. So something like KNN, but at scale in a performant way. If you are interested, please just reach me on LinkedIn, Twitter, however you want. But if you have any questions, I would be happy to answer those. No questions? Okay, then thank you very much. I will be still on the conference. If somebody wants to talk, I will be happy to. Thanks a lot.